Hello, my name is Ajiboye Isaac, and this is another opportunity to learn further mathematics. And today we want to discuss inequality, um, concentration on quadratic inequality in one variable. Quadratic inequality in one variable. Remember that we had discussed quadratic inequality in one variable in our previous lesson. We consider a particular method, which is an analytical method, all right? And today we want to look at a second method. We want to look at another method. So our learning objective at the end of the lesson, learners should be able to apply basic inequality rules to determine the solution set of a quadratic inequality in one variable using graphical method. Okay, in the previous lesson we used an analytical method where we stated that if we multiply two things and it's giving us positive number or positive result, it means that the two things are positive or the two things are negative. On the other hand, if we multiply two things and we're getting a negative, that means either of the two things is negative. So in this case, we are using graphical method. We are not using the analytical method to solve the quadratic inequality in one variable. So at the end of the lesson, you should be able to solve a quadratic inequality using graphical method. And this method seems to be seems to be a lot easier and more applicable. All right. So let's take a look. Our key vocabulary words: inequality. It is a relation comparing two relatable quantities. It can be greater than, less than, or equal to. We should be familiar with the signs, the inequality signs. We have the less than, which is the folding of your left elbow, the negative. If A is negative, or if A is less than 0, it means that A is negative. And when the number is greater than 0, it means that that number is positive. So we also have less than or equal to sign and greater than or equal to sign. Okay, then we have quadratic inequality in one variable. That is when we have ax squared plus bx plus c greater than or equals to 0, and also ax squared plus bx plus c less than or equal to 0. These are quadratic inequalities in one variable. So the method 2, that is the second method. All right, we have looked at the first method in the previous lesson. So this is the second method. This method involves the graphical solution of the quadratic inequality in one variable. So what we are seeing now is that we are going to display the solution on a graph, and from there pick our solution set that satisfies the inequality. I'll say that again. We will express the solution on a graph, okay, and then from the graph we'll pick our solution set. We'll pick the range of values that satisfy the inequality. Recall that the graph of f of x equals to ax squared plus bx plus c is a parabola. That is, if d is greater than or equals to 0, the parabola crosses the x-axis at two distinct points. This fact can be used to solve quadratic inequality of ax squared plus bx plus c greater than or equal to 0, or ax squared plus bx plus c less than or equal to 0. What we are saying there is that you can have a quadratic graph. You can plot a quadratic graph and you would know that it will be a parabola. In any case, if the d is greater than 0, then we would expect that the parabola will cross the x-axis. Okay, in the diagram just by the side, that's a graph for f of x equals to ax squared plus bx plus c. And you will know that x above x-axis is positive, below x-axis is negative. Okay, above x-axis is positive and below x-axis is negative. That is when you have your y-axis. The y-axis, the mark or the values of the y-axis above the x-axis is positive, and the value of the y-axis below the x-axis is negative. All right, so we put that in mind. Now, you know that whenever you draw a quadratic graph, where the graph cuts the x-axis are the roots or the solution of the graph of the quadratic equation or the quadratic relation. Okay, so let's call that place where the graph cuts the x-axis as alpha 1 and beta 1. Also, note that when the coefficient of x squared is positive, where the coefficient of x squared from the relation ax squared plus bx plus c, coefficient of x squared is a. So if our a is positive, all right, it therefore means our quadratic graph will appear like a u. But if a is negative, the quadratic will appear like an n, like an inverted c. All right, you can see in this case too. So going back, in case 1, we are looking at the case where the coefficient of x squared is positive. The coefficient of x squared is positive, and so we have said that if the coefficient of x squared is positive, then our graph will appear as a u. Noting that where the graph cuts the x-axis is the solution. So we have alpha 1 and beta 1 as the solution of this graph. Okay, so alpha 1 and beta 1 are the zeros of f of x equal to ax squared plus bx plus c. Then for the intervals, okay, x less than alpha 1 or x greater than beta 1, you will notice that those are the regions where the relation, the quadratic relation or the quadratic expression is positive. That is, ax squared plus bx plus c is greater than 0. On the other hand, for the interval between alpha 1 and beta 1, that is, alpha 1 is less than x less than b1, you will notice that the relation is negative. That is, ax squared plus bx plus c is less than 0. I'll say that again. Let me just, without reading. If you look at the graph, before alpha 1, all the values before alpha 1, if we have x before alpha 1, that means x is less than alpha 1. You see that the graph is above the x-axis, and that means it is positive. Again, when you look at the graph, after beta 1, the values of the quadratic expression or relation is positive. Okay, so the solution, suppose that we're given a quadratic inequality in variable 1 as ax squared plus bx plus c greater than 0, it simply means that you should look at the solution set for which that relations are positive, right? And then if you look at the graph, okay, let's say you now plot the graph, you now look at the graph, you see that the values before alpha 1 are where the graph is positive, and the values of after beta 1 are where the relation will be positive. So those are the two solution sets when they ask you to pick or to find the values of x, or the solution set where the relation is positive. On the other hand, you can be asked to find where the relation is negative, ax squared plus bx plus c less than 0. You will see that those values between alpha 1 and alpha 2 and beta 1 rather, alpha 1 and beta 1 would have the relation to be negative. That is, the graph will be below x-axis, and because the graph is below axis, the relation is considered to be negative. So the values between alpha 1 and beta 1 will give a negative values of the relation. Okay, so for the interval alpha 1 less than x less than beta 1, we have ax squared plus bx plus c to be less than 0. Okay, case 2, we can have our coefficient, the coefficient of x squared, a, to be negative. when the coefficient of the coefficient of x squared, a, is negative, then the graph will be inverted. Okay, the u will be inverted. Now, in the case here also, we can have a situation where we are asked to find the relation. The relation is greater than 0 and the relation is less than 0. If you look at it, the graph carefully, above x-axis, the relation is positive. That is, the graph is positive. Below x-axis, the graph is negative. So above axis is greater than 0 and below the axis is less than 0. Okay, so when you now ask to find f of x greater than or equal to 0, you are only going to consider the values above the x-axis. And if you are asked to find f of x less than or equal to 0, you are going to consider below x-axis. Okay, now you will look carefully at the graph. If you look carefully at the graph, we have alpha 2 and beta 2 as where the graph cuts the x-axis. And if also you look at it, if we have f of x equal to ax squared plus bx plus c, and we have it as less than 0, that is, our x is before alpha 2 and our x is after beta 2. Those values before alpha 2 and beta and after beta 2 will give you a negative value of the relation, that is below the x-axis. Whereas the values of the relation will be positive for the values of x between alpha 2 and beta 2. Do you get it now? Look at the graph. Between alpha 2 and beta 2, the values of the relation, the graph, the part of the graph is above the x-axis, and that means the values of the graph are positive. And before alpha 2 and after beta 2, the values of the graph are below the x-axis, and that means they are negative. Okay, and so if they say the relation you should find the values or the solution set for which the values are positive, that is greater than 0, you are going to pick the ones above. And then when you say below the x-axis, less than 0, you are going to pick the value below. Okay, example will make it clearer. Let's look at the example. Find the solution set of x squared plus x minus 6 greater than 0. Okay, that is, if you look at this, we are going to plot that quadratic x squared plus x minus 6 and pick the region on the graph where it is positive, because we are saying it is greater than 0, and we are saying that when anything is greater than 0 is positive. So we are saying the values of x where the relation is positive. So ordinarily we would find the zeros of the quadratic inequality just by factorizing. And then if you factorize the quadratic the quadratic expression, just by factorizing the usual factorization method, you have two factors. X plus 3 and x minus 2 are the two factors. Okay, so the zeros of this quadratic expression would therefore be, when you equate the two factors to 0, x plus 3 equals to 0 or x minus 2 equals to 0. And then when you do that, your x will therefore be equals to minus 3 and x will be equals to minus 2. Sorry, x equals to minus 3 when you take the 3 to the other side, and x will be equals to 2 when you take the minus 2 to the other side. So if you now display that on a graph, okay, or you can see the graph we have there, where the graph cuts the x-axis is therefore the zeros. Okay, so we have minus 3 and 2. Those are where the graph cut the x-axis. Now, what we are saying here is that above the x-axis. The values of x that will give the graph above the x-axis will be before -3. And the values of x for which will be above the x-axis will be before -3 and also after 2. However, the value of x or the values of x for which the relation will be below the x-axis, those are the values between -3 and 2. You get it now? I'll say that again. If you look at the graph, where the graph is divided into 2, above x-axis and below x-axis. Above x-axis are positive, below x-axis are negative. Okay, now that graph, if you look at the graph, we have the roots or the zeros of the graph, okay, which is -3 and 2. The values of or let me say the graph is positive when you have the values of x before -3, and also positive when you have the values of x after 2. On the other hand, between -3 and 2, the value or the graph are negative. They are below the x-axis. Okay, so when you go to the relation say the values that are positive, that are greater than 0. Do you see now? The values that are greater than 0. Hence, the solution set of x squared plus x minus 6 greater than or equals greater than 0 will therefore be x is such that the x are before are less than -3. That is, x less than -3 means x are before -3. Union x is such that x is greater than 2, that is, the values of x that are after 2. Okay, so when you take the union together, you combine the two. Okay, x before -3 and x after 2, the union of the two are where you will get the values of the graph to be positive. So graphical representation, you now have x before -3 to the left and x after 2 to the right. That is the solution, which is the same as when we use analytical method in our previous lesson. Okay, example 2. Show graphically the solution set of x squared plus 3x minus 4 less than or equals to 0. That is, when you plot the graph, we want the region where your graph is negative, because we said less than or equals to 0. We want the region where the graph is negative. Okay, so the usual method, you factorize the quadratic inequality. Get the zeros of the quadratic inequality. Okay, you may say, Uncle, how do we get the zeros? When you factorize, you equate each of the factor to 0 and make x to be subject. For instance, when we factorize this, when we factorize x squared plus 3x minus 4, what we get is open bracket x minus 1 close bracket, open bracket x plus 4 close bracket. To get the 0, we equate it to 0. Okay, I mean, you can go through the methods of factorization there. It has been well explained, that it has been well displayed, all right? But I know that you know how to factorize. So, therefore, the zeros, you will equate x minus 1 to 0 and x plus 4 equals to 0. So, if x minus 1 is equal to 0, it therefore means x is equal to 1. And if x plus 4 is equal to 0, it then means x is equal to -4 when you take the plus 4 to the other side. So the zeros therefore are -4 and 1. When you display that on a graph, the relation says find the relation where it is less than 0. Where it is less than 0. So before -4, the graph is positive. After 1, the graph is positive, because the part of the graph is above what? The x-axis. Now, between -4 and 1, the graph is below the x-axis, meaning what? The graph is negative. All right, so but they want us to find where the graph is negative. So that is between -4 and 1. Hence, the solution set is -4 is less than x is less than or equal to 1. That is the meaning of between. When you have something between less than x, less than let's say we have a is less than x and less than b. That means x is between a and b. That's what it means. All right. So hence the solution set is -4 is less than x is less than 1. And then when you display that on a number line, you have x between -4 and 1, which is the same as the solution we got using analytical method in our previous lesson. For me, I find this method very easy because it's pictorial. Once you look at once you just display the factors or the zeros on a graph, then you can know which one is if they are asking you to get the values below or get where the graph is negative or where the graph is positive, and you just pick out those values, and then it becomes easy. All right. I want you to try out this classwork. Try out this classwork. Use the graphical method to solve this classwork. What are you going to do? First, factorize the quadratic expression. After you factorize, you find the zeros. Then when you get the zeros, draw the graph and put the zeros on the graph. Then when you put the zeros, then you go to the question. The question says greater than 0. So pick the region for which the graph is above the x-axis. Pick the region for which the graph is above the x-axis. And you do that. Then you forward your attempt to my WhatsApp number so that I can guide you aright. Then attempt the assignment as well. Is similar, all right? In this case, you factorize. When you factorize, you then find the zeros. When you get the zeros, you express the zeros on a graphical display, and then find the values of or find the set of x for which the graph is below the x-axis or for which the graph is negative, and you'll be able to do that. All right, so these are the classwork and the assignment. Forward your attempt to my number, and I really want to commend those of you that have been attempting. You are really learning. You may not know how this has been insightful. You will not know until maybe when you get back to school and you are better than your mates. Keep it up, and God will crown our effort. Thank you for listening. See you in our next lesson.